know at 6 seconds what the velocity is. So question number 3, write it first. Find the velocity at 6 seconds. Oops, no question, direction. Find the velocity at 6 seconds. So from our training on our tables, we know we're going to go up from 6 seconds and make a dot, and then create a tangent line there. From that, you make a triangle and do a rise over run, or you can do the algebraic approach, y2 minus y1 over x2 minus x1 on the endpoints of your tangent line. So the quicker way is geometric on this one, but you're welcome to do either. All right, on the graph, let me see the tangent line that you've constructed. All right, go ahead and calculate rise over run. We're at 6 seconds, so put a dot and draw a tangent at that point. So it's actually kind of mimicking the graph there because it's kind of straight anyway, isn't it?
Yeah, it is.
That's fine. It can touch the graph if the graph is straight. All right, so create a triangle, a right triangle. That's the hypotenuse. Now create a right triangle. So Hunter, what we're doing here is we're somewhere in here at 6 seconds, and we have a dot, and we created a tangent line, and now we're making a triangle out of that. And guesstimating, estimating, it's not going to be exact. What is the rise? I just pull this distance in my eyeball over here. How many units is it in centimeters? And then I pull the rise, I look down here and find seconds. So if I use the rise over run method, what numbers are you getting? Emily Davis?
Yeah, 4 over 4.
4 over 4. I had used a smaller triangle and got 2 over 2, which gives us the same result. Anyone get anything vastly different? So she got 4 centimeters over 4 seconds, which is 1, and what kind of precision is this chart giving us? Not much. It looks like we can only use 1 significant digit here. So we have 1 centimeter per second. How did yours work out, Emily Martin?
I think I drew it wrong because mine was like longer on the tangent.
Well, shouldn't matter because as you go longer on this side, it'll be longer on that side. So proportionally, when you divide, you should still get 1, but you didn't.
Well, because mine was the rise was 3 when I drew it.
Yeah, but it should match a larger run. All right, and notice these are by 2s. So this is 2, 4, 6. Okay, how about yours? 4 over 4?
3.
Okay, that's fine. It's close enough. They're not going to be exact. That's 1 1/3 is pretty good. Now, when you draw it that small, it's going to be hard to measure over here, but you can try a little bigger one. So that means where are you at 6? So you can make your tangent line longer.
Oh, like that long?
Yeah, it doesn't matter how long it is, but your triangle will be easier to work with.
Okay, that makes sense, yeah.
And make sure it's a right triangle. So this is straight, up and down, vertical, and this is horizontal. Right, mine wasn't there. You can improve on it. All right.
But that's only
good.
1, and then it's 2.
All right, but this is, well, if you look at this scale, there's 2.
Oh,
so it's
yeah,
2 over
you're
2.
right.
Brian,
Gotcha.
what, rise over run for your triangle? What do you get?
Rise was negative.
Yeah, we'll worry about the negative one in a minute.
1 over 2.
All right, but see, these blocks are by 2s.
All right, but
So this is really
so
a
it's
2.
negative 2 over 4.
Right.
It's still negative 0.5 slope.
4, let's see, you've got from here to here, that's 2, and this is 2. See, this is on one, all right, 2, yeah. All right, and the only thing you have to remember from our slope practice this morning is that when it goes in this direction, it is a negative slope. So you're going to go in and put the answer, find the velocity at 6 seconds, and we're getting very close to -1 meters, is it meters, centimeters, sorry, per second. So, all right, one more of these, and then we'll look at our OYOs, which I think you'll be better able to do you think? Some people were complaining that they didn't really feel confident in what they were getting. I have to stop.
No, can you move the tissue box?
Oh, certainly. All right, last one on our practice graph here. I want to know the slope. What is the slope? Number 4. Find the velocity. Same as number 3, but we're going to pick a different point. Velocity at 12.5 seconds. So we're going to do the same thing over there at 12.5 seconds. So create a dot above the 12.5. From that dot, create a tangent line. And then from that, create a right triangle. Good. Okay, now make a triangle. That's a good. That's going big. All right. So without the algebra, let's just look at this. What's the rise?
Probably.
You read it over here. It's the difference between here and here. They're each 2. So from here to here would be
-4.
right. Well, we'll just say 4. We'll worry about the sign in a minute. And from here to here is how many?
1.
Right. So rise over run is 4 over 1. And because it's in this direction, we learned that's a positive slope. All right. All right. Alex, what was that answer again?
4 over 1.
All right. 4 centimeters per second is a reasonable answer. How close was yours, Brandon?
I think it will.
Okay, that's possible. Okay, it's possible depending on how you drew your tangent line. So I will be able to check those in your work, and I won't expect the exact same answer from everyone. Zach, yours okay?
4 over 1.
Okay. Awesome. All right. Let's go ahead then and look at the OYOs now. If you could pull those out, we can fine tune them and see how they are. Pull out your homework. 1.4, 1.5, and 1.6. Oh, no, yeah. 1.4, 5, and 6. They had a graph for you. Let me see. All right, and I actually had I had copied it for you, so you're actually on that paper. Is there any answer you want to change now at this point? The first question is, is the object moving faster at 3.5 or 8.5? Take that one, Emily Martin, and tell me what you think and why.
I should probably change this.
Okay, well, just think out loud.
Okay. I didn't realize the graph counted by 2 again, so 1 second.
So looking at the slope at 3.5 and 8.5, which is slopier? I don't need a number. I just need to know which one is at the steepest point.
8.5 or no, 3.5.
3.5? Yeah, 3.5. If you're on skis, you're in trouble at 3.5. If you go up from 3.5, it's very steep. 8.5, there's some steepness there, but it's not as much as a 3.5. Were you convinced? All right. Number 2, or that second one, 1.5, how many times does the object change direction? Okay, we're going to be spinning around on this one. Emily Keene, how many now that we've had some more training?
I had 5 times.
5, and that is correct. You're counting the peaks and the valleys. So, if you didn't get 5, let me point them out to you. Can you see? Hunter, can you see? There's a mountain. There's a valley. 1, 2, mountain, 3, valley, 4, mountain, 5. Those are the direction changes. I would take ourselves through a finger trip, but it would take about 15 minutes, so we're not going to go there. Yes, Brandon?
Okay, I did get 5, but How come, like, when you just did that, how come you didn't count the last valley? Like the last one going down?
Right here?
Yeah.
We're not sure. The problem stopped there, so we don't know if it's going to go continually down in that direction. So we
And
don't
so
know.
wouldn't it still
We don't
count
know
as
if that's a valley or not.
To activate the full valley, you can't just start going down the other direction?
Yeah, it has to dip and come back up to be a valley.
Should be, okay, to be a change, okay.
Okay?
I think so.
All right, any other questions on that? All right, the third one is, what's the instantaneous velocity at 1 second? So we're just going up from 1, putting a dot, drawing a tangent line, drawing a right triangle, getting the rise over run. And an answer that you can share with us. Alex, do you have one?
Oh, for the first one?
It is the third one.
Third one, wait. Oh.
So the question was, what is the instantaneous velocity at? Oh, you're on the wrong graph. There we are. We're going over those. You didn't do that.
No, I did. It was just the answers. I put them on the,
Oh,
the back.
okay,
I
okay.
forgot the graph was in the back, and then I was like, wow.
Okay. All right. So the third one. What did you get there?
I got 1.1.
1.1. That's
Yeah.
pretty good, because if you draw the obvious triangle that actually almost matches the graph there, you get a rise of 2 over a run of 2. So 1 is a reasonable answer. So you were very close. You were more accurate than I was. All right. All right. So those are going to become more doable for you the more we talk about it. Let's look at our next topic. Our class ends at
35. So like 5 minutes.
That's
Alright.
chapel.
Oh yeah, so wait a minute. Thank you. Should have changed that this morning. Could you do the honors? Alright. I will just get to say a little word about this, day 6, and give you your assignment, and that'll be it.
Wait, you said day 5?
Yeah, that was day 5. You should have had